It's here, new chapter, chapter 5. It's about polynomials, but today we're going to talk about exponent rules and how we use those and going on about our business. When we look at chapter 5 here, some things we notice is when we look at all these different things, whether you know how to do them or not, you notice the exponents. Everything really has powers, and a lot of times these are higher powers than we've seen and dealt with in the past. If you multiply this out, then we got an x to the third. When you look at all these powers, the reason that we're going to do what we do today is to deal with powers like that. So that's the idea here as we move forward. You may know all these exponent rules. This is all really Algebra 1 stuff. What happens is we use all these exponent rules to do kind of complex problems. So we'll go through these real quick. When we talk about what the product rule is, product means multiplication, so you're multiplying two things together. Well, by definition, x to the fifth means there's 5x's, and x to the third means there's 3. So that means 8x's altogether. So really, when you're talking about this in summary, anytime you're multiplying expressions with a common base, you add the exponents. And so that's what the product rule is, right there at the top. Multiply anything with a common base, notice it's x and x, then we can add the exponents, a plus b. Going next, quotient rule, when you look at what this really means, x to the fifth means x times x times x times x times x. X to the third means 3 of them. When we go on, we say, hey, you know what? These can kind of reduce or cancel or simplify, so we got x squared. In summary here, when you divide things with a common base, you subtract the exponents, and that gets back again to what our exponent rules are. Anytime you divide, we're subtracting the exponents. Keep going on, talk about the power rule real quick. Again, we're going to talk about what this really means. X squared to the fifth means that there's 5 of those x squared things. Well, x squared means there's 2 x's each time. So there's 5 groups of 2 x's, in other words, x to the 10th. So you could summarize this when raising a power to a power, you multiply. So 5 times 2 gets you straight down here. So all these exponent rules are basically shortcuts, so you don't have to show all this work all the time. And so as we kind of keep going, negative exponent rule. Well, there's two different ways to think about this. One is if you think about what the actual x's mean. So you got all these x's and you cancel them and you'd be left with a certain amount. If you use the rule, you go this way and okay, 3 minus 5. In either case, you get something that looks a little different. This one's -2. This one's 1 over x to the second. The thing is, these are equivalent. These are equal to each other. And so all the negative exponent rule says that there's a different way to say it. So instead of saying negative power, we can say a reciprocal or flip it over, 1 over 2, or sorry, x to the 2. So as you look at the negative exponent rule, that's just two different ways to say something. You can either say something with a negative exponent, or you can say something as a fraction. They really mean the same thing. Zero exponent rules, you've probably already heard anything to the 0 power is always 1. The question is, why is that? When you look at this pattern, 16 down to 8, 8 down to 4, 4 down to 2, what's happening? Well, you're dividing by 2 every time. So what would come next? What's supposed to be here? Well, 1. 1 is supposed to be there. That's what it's supposed to be. Divide 1 by 2, you get a half. Divide this. If this isn't 1, a lot of patterns don't work. So that's one of the reasons why anything to the 0 power is always 1. It's an abstract idea, but it means just ones. There's all 5 of the exponent rules. Now, basically, you just use these rules and you kind of do stuff. So all these problems are just order of operations. So as you try to go through, you say, hey, can I do anything in the parentheses first? No, this is as simple as it gets. Can I do anything? Can I deal with this exponent? Yeah, you know what? I can. So when you distribute an exponent, you're distributing it to each of these things. So distributing to all 6. These are all multiplication, so we can kind of deal with any multiplications here, which there's not much to do. As you go through, I would take and simplify each one in sort of pairs. So the numbers, the x's, and then the y's. When you go through and kind of think about these in different things, so the numbers just you cube them and you're good to go. For the x's, you have x to the 9th over x to the -6. Well, one thing you could do is 9 minus -6, in other words, 15. So x to the 15th. That's why x to the 15th is on top. Or you can think about flipping this and say, hey, you know what? Instead of this being at the bottom, I could flip it to the top and it becomes to the positive. So then 9 plus 6 is 15 and it'd be on the top. So that's one way to kind of think about it. With the y's, you can think about the y's similarly, y to the third over y to the 12th. If you want to think about how you work this out, you can say, hey, you know what? This is 3 minus 12, so that's negative 9. Negative tells us that the y should really be on the bottom here. And the other thing you could do would be the canceling idea. But there's your final answer in this case. Let's try one more here. You got something like this. Again, it's order of operations, and you can kind of go through anything you can do in the parentheses. You can do that. Then you deal with the exponent. So in this case, this would be distributing. So we distribute that to those. Once you distribute, you get something like this. One way to do this is to take any of these negative powers and to flip them. So all those negative powers got flipped down to the bottom. That helps us kind of organize our stuff. So, and then we just reduce them. Say, hey, you know what? Let's see. The x's, so that's x to the fourth, and on the bottom, x to the ninth on the top. So 9 minus 4 is 5. Positive 5 means x to the fifth's on top. You could do the same thing with the others, with the y's, with the numbers, etc. But this is our answer down here. Okay. You should be able to know all the exponent rules. You should be able to use these to simplify different complex problems like we just did. And if you can do that, you're good to go. So good luck.